Hi students, in last class we have discussed regarding the fundamental compensation by sectioning, that is model 3 question. Today we shall discuss regarding the model 5 question. First question, explain the effect of harmonics on electrical equipments. This topic will come under harmonics unit. Effect of harmonics on electrical equipment. The main thing what they are saying is blown capacitor fuses or failed capacitors in a power capacitor banks are the first evidence of a excessive AC harmonic level. First you need to remember is capacitor fuses or a failed capacitor. How we will come to know? By if failed capacitors or the fuses by indication, by the fuse indication and the failed capacitors in a capacitor banks are the evidence of main is that is evidence if any capacitor banks fails or if any capacitor fuses it that is indicate blown capacitor fuses, then that is the evidence of a excessive AC harmonic level. That first point you remember. Next, second point is this capacitor we are using. Okay, so the manufacturers what they will indicate. Okay, American National Standard Institute's standard, that is C55.1 at 1980 and NEMA CP1 1973 cover the characteristics of shunt capacitors. In the standards they consider or they give a main attention is to attention on harmonics. Okay, considerably attention is given to harmonics, and allowance are made for increase in both the effective voltage and current due to harmonics. Continuous operation with excessive harmonic current, if it is harmonics it is indicating, or blown capacitor fuses indicating, or any failed capacitor is there. Okay, capacitor banks have failed, this level is there. If we go on in operating continuously, then it will lead to what? It will lead to a increased voltage stress and over temperature and can shorten the life of the capacitor. For example, small harmonics we will think that we can neglect that harmonics, but that lead to what? It can lead to increased voltage stress and also the over temperature. Continuous operation with excessive harmonic current can lead to a increased voltage stress and over temperature and can shorten the life of the capacitor. If we go on using that, the life of the capacitor will be reduced. First point, blown capacitor fuses or failed capacitor, that is the evidence of excessive AC harmonic levels. Next, you remember the manufacturer, then you can write that. Next, you remember the if a fault is there, if we operate like that only, then it can lead to what? It can lead to over voltage or increase voltage as stress, and it will become a over temperature also. That leads to what? It leads to shorten the life of the capacitor. Next point is that typically a 10% increase in voltage stress will result in a 7% increase in temperature. For example, if 10% is increased in voltage stress, that will lead or that will result a 7% increase in temperature, and that will reduce the life of the expectancy or life of the particular equipment to a 30%. That is what happens in the capacitor banks, or that is what happens in the electrical equipment. This life analysis does not allow for capacitor failure initiated by dielectric corona. The damage done by corona produced by how the damage done by corona produced by excessive peak voltage depends on both the intensity and the duration of the corona. You might have read regarding corona in the transmission and distribution subject, right? Cable. And harmonic currents can cause the overheating of rotating machinery, particularly solid rotor, that is non-salient pole synchronous generator. What they are saying is harmonic currents can cause a overheating of rotating machinery, particularly solid rotor, non-salient pole synchronous generator. Harmonic currents produce a magnetomotive force that cause current to flow in the solid rotor surface, adding to the heating. Okay, harmonic current can cause what? It will cause a overheating of the rotating machines, particularly what? Particularly solid rotor, that is non-salient pole in a synchronous generator, and that can produce a magnetomotive force that if it produces a magnetomotive force that causes a currents to flow in the solid rotor surface, and it will increase the heating process. It will increase still more heat. Positive sequence rectifier harmonics, that is rotate forwards and cause harmonic order 6, 12 and so on in the rotor. Those harmonics following the equation, that is n is equal to k into q minus 1 are negative sequence rotate against the rotation of the rotor, and again produce harmonics order 6, 12 and so on in the rotor. Those harmonics n is equal to k into q minus 1, that is for negative sequence. They are rotating, they are having a negative sequence and rotate against what? Rotate against the rotation of the rotor, and again they produce a harmonics order is 6, 12 and so on in the rotor. The resulting, because of harmonics, the resulting pulsating magnetic field caused by the oppositely rotating pace of magnetomotive force sets up localized heating in the rotor, which may require a derating of the machine. The derating for 6 pulse operation, where the 5th and 7th harmonics dominate, can be considerably depending on the particular machine design. Derating means we need to reduce that rotation speed, that is derating for 6 pulse, it will be increased speed, so we need to reduce the speed. Derating for a 6 pulse operation, where the 5th and 7th harmonics will dominate that, and can be considerably depending upon what? Depending upon the particular machine design. Derating for a balanced 12 pulse rectifier operation is generally minimal. The presence of rotor amortization, that is amortizer windings, greatly alleviates the rotor heating problem. The presence of this rotor windings, rotor amortizer windings, that will alleviates the, or it will deviation the rotor heating problem. Induction motors are much less affected by a harmonics than solid rotor synchronous generator. You can write the points regarding first point, blown fuses, that is blown capacitor fuses, failed capacitor in power capacitor banks are the first evidence of excessive AC harmonic levels. And next you can write regarding manufacture. Next that can lead to increased voltage stress and over temperature, and you can write the regarding percentage in voltage stress, and that will increase the percentage in temperature, and reduce the life expectancy. And you can write the damage done by corona produced by excessive peak voltages depends on what? Depends on intensity and duration of the corona. And harmonic currents can cause a overheating of the rotating machines, particularly solid water synchronous generator. And that what happens if overheating of the rotating machines, that will produce harmonic currents, will produce a magnetomotive force that will cause a current flow in the solid water surface. And the positive sequence harmonics, negative sequence harmonics, the result of the pulsating magnetic field because of rotating opposite to the rotation of the rotor. So what happens if it rotates against the rotation of the rotor, so it will produce some harmonics that it will increase the speed of the rotation. And due for deviating of a balanced rectifier operation, for deviating deviating for a 6 pulse operation, 5th and 7th harmonics need to be considered. That is it will dominate. So depending upon the particular machine design, they can deviate the pulse operation. And the presence of rotor armature windings, it will deviate the rotor heating problem. It may increase or it may decrease depending upon the rotor windings, the presence of rotor armature windings. And next, induction motors are much less affected by harmonics than or solid rotor synchronous generators. Harmonic currents carried by transformer will increase the load loss by a factor what? Greater than the increase in RMS current. That is, harmonic currents carried by transformer will increase the load losses. Okay, harmonic currents carried by transformer, what happens if it carried by transformer? It will increase the load losses. Next, a designer of a reactor need to know what he need to know? The amount and order of each significant harmonics, so that they can apply the proper factor for I square losses contributed by the fundamental and each contributing harmonics. This you need to write for 10 marks if they ask. Points I have said once again. So what points you need to write? They are easy topic it is. Read nicely and write nicely. Okay, all the best for the exams.